Okay, we are going to look at some sample problems for non-Mendelian genetics, which is non-typical inheritance where you don't have a simple dominant and a simple recessive. Our first type is incomplete dominance, and this is when the two traits blend. Often flowers are used in these examples, which is what we have here. This is giving us a plant with red flowers and a plant with white flowers. So red genotype is going to look like this. White will look like that. We'll do our Punnett square. Okay, and the problem asks us for the genotypic and phenotypic outcomes. In this case, we only have one outcome. So for genotype, we will have RW, which gives us a phenotype of a blended red and white is going to give us a pink trait, and that's our only choice, so that will make it 100%. Our next problem is looking at codominance and multiple alleles. For codominance, you see both traits. So both traits are expressed, and with multiple alleles, that means there's more than two alleles. So more than two. Blood type is a great example of this because it is both codominance and multiple alleles. You can have AB, or type O blood. That would be the multiple allele part, and it's codominant because you see both that you can see both the A and the B trait. So for our example, we're going to look at two people with type AB blood. Okay, so that would be AB, that genotype. Okay, we're going to do our Punnett square. Okay, so we end up with one type A, one type B, and two type ABs. So it asks us for the genotypic and phenotypic outcome, so we have to write the genotypes again. Okay, so this is going to give us type A blood, type AB blood, type B blood, 25% chance here, 50% chance here, 25% chance here, which is going to give us a 1 to 2 to 1 ratio. Okay, on the back, we're going to look at sex-linked traits, which are going to be traits that are found on the X chromosome. We're always going to use XX and XY for when we work these problems. Our sample problem is a hemophilia problem. Oh, well, our first sample problem just wants us to show where the X and Y's come from, actually. Okay, if this is the dad, this is the mom. Okay, here is a daughter, 1X, 1X. Here's a son, an X and a Y. Here's a daughter, here's a son. The question says, from which parents do sons get their X chromosome? Sons get X from mom. Okay, they get their Y from the dad, and from which parents do females get their X chromosome? Daughters get, let's see, let's look here, one from each parent. Okay. Now our problem is asking about a hemophilia trait. We have a hemophiliac man, so he's XY, and it has hemophilia. It says up here that hemophilia is recessive. Okay, so his hemophilia trait is recessive and it goes with the X. She's a carrier, so she doesn't have the disease, which means she must have one of the dominant alleles, but she carries it, so this is where she carries it. Okay, so here's our Punnett square. Let's take a look at it. Daughter that's a carrier doesn't have it. Here is a son that does not have it. Here's a daughter that does have hemophilia, and here is a son that does have hemophilia. If there's no dominant allele, that means they have the disease. So these two, probability that they will have a child with hemophilia, it is a 50% chance that they will have a child with hemophilia.